Okay, good morning, grade 11s, or afternoon if you're listening to this in the afternoon. We are going to look at 7.8 today. This is where we put everything from chapter 7 all together. So we're going to be finding quadratic equations, usually in real life or in other problems, and using either in standard form or factored form, vertex graphing form, or the quadratic formula to solve or find the value for x that will work in the problem. Okay, let's have a look at this first example. It says a right triangle has lengths of these sides, x, and the second side is 2x plus 4, the third side is 3x minus 4. We are supposed to write a quadratic equation to determine the value of x. And is there more than one solution? Well, when we look at these side lengths, and I have written in one hypotenuse already, we do not know which length is going to be the hypotenuse. We know that the hypotenuse has to be the longest side on a right triangle. But we're not sure, just from looking at our options of sides, whether the 2x plus 4 would be longest or the 3x minus 4 would be longest. There's different values of numbers. Say, for example, if x was 2, and we put a 2 in for x here, we'd get 2 times 2, 4, plus 4 would be 8. And if I put a 2 into this last third side, it would be 3 times 2 is 6, minus 4 would be 2. So if x is 2, obviously 2x plus 4 should be the longest. But we're going to do it, find the equation, just looking at 3x minus 4 being the longest side. Okay, then let's write an equation here. I'm going to write in the x and the 2x plus 4. What equation do you know for a right triangle where we know all three sides? Dun, dun, dun. I'm hearing some of you say Pythagorean theorem, which is true. Remember that. It's a squared plus b squared is equal to c squared. As soon as we start squaring variables, dun, 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 we're going to get a quadratic equation. Okay, so let's plug this in. A is one of the sides, so let's call this side A, and this side B, and then the hypotenuse is always C. So let's plug those into the equation. We will have x squared plus B is 2x plus 4 squared equals C 3x minus 4 squared. Okay, now all you have to do is multiply this so that we have something that's factorable. So we could find the value of x by factoring, or something that's in standard form, so we could take the a, b, and c and put it into the quadratic formula. Or, yeah, I think those would be the two best options to help us find x. So I'm going to pause it after I write this out one more time just to help you. So we know that squared is multiplying by itself, right? So we're going to FOIL that and also FOIL this. Okay, pause and do that foiling and gather your like terms. Okay, here I have multiplied everything together and gathered the like terms on either side of the equal sign. Now I'm going to go ahead and I'm going to take all of the terms on the left over to the right side of the equation. I'm doing this as opposed to the opposite because if I subtract 5x squared from 9x squared, it's going to be positive when I move it to the right side of the equation. Okay, pause and you do that too. And there we have the quadratic equation in a nice form. I think this looks easiest to solve for x by simply factoring it. When I factor, I look at the greatest common factor, and in this case it would be a 4x. So that would leave me an x minus 10. Okay, and from those two factors, in order for this equation to equal 0, I should be able to find the values of x. So from this first factor of 4x, I can see that one of the options for x is 0. Now, already I can tell that 0 would be inadmissible. It would make the length of this tall or up and down vertical side to be 0, and there would be no triangle. So this seems like inadmissible. Oops, there we go. From this second factor, I can see that in order for the value of x that would make it 0, would be 10. And from that, I can find my sides. So if x is 10, then this side will be 10. Here, if x is 10, this will be 30 minus 4, 26. Did it say if this the units here? No, it didn't. And here, if x is 10, 20 plus 4, that would be 24. Okay, let's move on to number 2. These type of number problems are popular for this section of quadratics. Often they will be asked to find consecutive even numbers, consecutive odd numbers, the square of an odd number, etc. Because when we multiply variables together, we get an x squared and we get a quadratic equation. So here it's asking us to find 3 consecutive, means in a row, odd integers. So for example, 3, 5, 7, 11, 13, 15, etc. The restrictions here are that the square of the largest of these integers is 33 less than the sum of the squares of the 2 smaller ones. Okay, so seems daunting and confusing when we read that sentence, but if we take it one step at a time, we can easily write up an equation to represent this sentence. Let's start, as we always do, in a story problem, with our definition of our variables. So we want an odd integer. When we say odd, we mean it's going to be one more than an even number. How do you determine an even number in math? Well, even, we know, is a number that's multiplied by 2. So we're going to say that 2, let's call it n for interest's sake instead of an x, 2n, that would be even. So any value you pick for n, if you multiply it by 2, it's going to be an even number. So this is an even number, and therefore that plus 1 will always be an odd number. And let's say that's the smallest number. We want 3 in a row. So the next number would be 2n plus 3. Remember, they have to be odd. Is the middle number. And 2n plus 5 is the largest number. Okay, so excellent. This is a great start, and now we can read the rest of the sentence here. The square of the largest integer, so let's write that down. Here's the largest, and we're going to square it. The square of the largest integer is 33 less than. So if this is 33 less than, in order to make it equal to, I'm going to have to add 33 to the largest, because we know that the value here is 33 less than the sum, meaning I'm adding 2 things, of the squares of the 2 smallest integers. Okay, so the square of the smallest integer, that's the smallest, squared, plus the middle integer squared. Okay, so we've got the sum of the squares of the smaller ones equaling to 33 plus the square of the large one. And that should work. Okay, now we're going to do the exact same steps. We're going to multiply everything through. We're going to gather like terms. We're going to make one side of the equation equal to 0. And then we're going to decide, how are we going to find the value of x? Which equation that we've learned about from quadratics, or about quadratics, will work to help us find that value of x? Okay, pause it. Do all that work, please. Alright, after doing that multiplying and gathering the like terms, again I chose to go to the right side of the equation to make it a positive 4n squared. Now we've got a trinomial here. It can be factored. At least I think it can be factored. Let's take out a greatest common factor first. Okay, and then when I factor that trinomial, let me see, multiplies to negative 12 and adds to negative 1. That would be n minus 4 and n plus 3. Okay, so we've got 2 factors here, giving us 2 options for our variable n. In this case, we see that n is 4. If n is 4, that makes the equation true. Or from this second factor, we see that n could be a -3. And that will make the equation true. Now, let's go ahead and figure our values out. So if n is 4, if I can fit this all on, if n is 4, then our smallest number, let's see, n equals 4. So then our smallest number would be 9, and 11, and 13. And if n is -3, then our smallest number is -6, 5, -6 plus 3, sorry, negative, and -2 multiplied by -3 is -6 plus 5 is -1. Okay, now let's just check if these options work. So I'll change colors. Here's my check. The largest number squared plus 33 is supposed to equal the smaller numbers squared. Check that one, and let's check the other ones too. The largest number squared plus 33 is supposed to equal the smaller two numbers squared. Okay, pause it and check those out, and both of those work. So our answers are here, these two possibilities for those numbers. Okay, flipping the page. Here we've got a diver question. You can see as modeled on the graph here, synchronized divers are performing matching dives from opposite sides of a platform that is 10 meters high. That's on the y-axis there. If two divers reach their maximum height of 0.6 meters above the platform, so 10.6, right, after 0.35 seconds, so they jumped up a little bit, how long then did it take them to reach the water? So from that highest point till the water, the bottom, how long is that? Okay, so it's telling us the vertex, isn't it? And that gives us a clue as to which equation we should use, probably the vertex graphing form, which we know to be y equals a times x minus h squared plus k. So we can easily plug the x and the y, the h and the k from the vertex into that equation. We need to be able to find the a first, and then once we have the equation, it will give us the amount of time taken there. Excuse me. Okay, so we know to find the a, we take one other point on the graph, and you can see that point. They've also given us this one. So let's stick that in for x and y and solve for a. Pause it, please. Alright, so after that work, we find our a value to be -4.9. And so our equation then of this diving parabola would be y equals -4.9. We know it's opening down. X minus 0.35 squared plus 10.6. Alright, now we were asked to find this point, right? The x coordinate of this. We know it's going to be something, that distance, and 0 would be the y. Okay, so if we know the x, it's easy for us to find the y. Obviously, we put the x in here and solve. If we don't know the x, it's more difficult to solve for y, although we can do it. The best option here would be to put this graph into Desmos and to analyze that. Let's see, though, if we can put a 0 in for y and solve for x. Now, I don't have time left on this video to go to Desmos and show you, but the ideal thing to do would be to type this into your graphing app. We can also solve for x. It's a bit of work, but we have two values down here for x. We can see that the negative value would be inadmissible. So this tells us that this takes 1.21 seconds from when they jumped off the board till when they hit the water. The question was from the highest point until they hit the water. And so we can see there we'd have to take 1.12 and subtract the 0.35 to find our final answer. Okay, and now there's this last question. I'm going to leave that one to you. I believe it's from the textbook, so you can look in there if you need to.